An island is 1 mile perpendicular to the nearest point A on a straight shoreline. So let's say here's our island, and here's our shoreline. So let's call that point A. And we know that this distance right there, that perpendicular distance, is 1 mile. Okay. And we know that a shaved ice stand is 3 miles down the shore from point A. So let's say that here is our shaved ice. If you don't know what shaved ice is, shame on you. So what do we say? We know that is 3 miles. And we want to know if a person on this island, let's say that this is our island point right there, they're on the shore of the island. If this person wants shaved ice, they can swim straight to the shaved ice if they want, like if this is all water right there. Or they could land somewhere on the shore, anywhere between A and the shaved ice stand. But here's the catch. We know the rate at which they can swim, and we know the rate at which they can run. Because of course you're going to run if you're going to get shaved ice. So we want to know where between A and shaved ice should we land to minimize the total time that it takes to get to the shaved ice stand. Okay? Well, let's think about it. Maybe I swim straight there. Maybe that's not a great plan since swimming is slower than running, but maybe it works. I don't know. That's an option. But maybe I land somewhere in the middle, like right there. And let's say we don't know how far we want to land in the middle, because, we don't know how far we want to land. But let's call that distance x. If that distance is x, what is this distance? Well, we know the total is 3, and we've gone x, so that distance is 3 minus x. Sweet. Okay. Cool. How does that help us? Well, let's erase this line real quick. Let's just look at this triangle we've created in pink. What would the hypotenuse of this triangle represent? It would represent the distance that we swim to the shore. And let's come up with an expression for that distance. Well, I know I'm dealing with a right triangle. A squared plus b squared equals c squared. C squared being the hypotenuse. So let's call that h squared so that we can be annoying. And a squared is 1 leg, which we know 1 leg is 1 squared. Plus b squared is the other leg, and the other leg we know is x. At least that's what we're calling it. So x squared. And that equals our hypotenuse squared. So what then equals our hypotenuse? Well, square root of that. So that can be expressed as 1 plus x squared. I hope you see that. It's a little bit of geometry. Okay, cool. What now? Well, now we have an expression. 1 plus x squared, the square root of that, represents the distance to swim. And we have another expression, x, which represents lies. We have another expression, 3 minus x, which represents the distance to run. Because if we land here, if that is our landing point from swimming, we have to swim that hypotenuse and run on 3 minus x to get to the shaved ice sand. And now let's do a little science. Let's remember that distance equals rate times time. And we are told in the problem that we can swim at a rate of 1.5 and we can run at a rate of 6 miles per hour. We're not very fast at running. I actually could totally not run 6 miles in an hour. I would faint and die. But what do we know? We know the distance. Those are the two expressions we came up with. We know the rate, and we want the time. So to get the time, we need to take our distance and divide it by our rate. So we need to write a time equation. And So let's figure out what our time equation is going to be. Well, let's take our distance on land, which is 3 minus x, and divide it by our rate on land, which is 6. Let's talk about units. 3 minus x, we're talking about miles. Miles. 6 is miles per hour. Okay, so the miles cancel and we're left with hours, because dividing by miles per hour is like multiplying by hours over miles, right? Whole idea of dividing by a fraction is multiplying by the reciprocal. It's working here. So we have that is going to represent our time on land. But we also have our time in the water. And we have an equation for the expression. We have an expression that represents the distance in water, which is the square root of 1 plus x squared, units being miles, divided by our rate, which is 1.5. Yes, I'm using a fraction. I know it's gross. Fraction, more like decimal. But that's our speed, 1.5 miles per hour. So again, the miles are going to cancel. We're going to be left with hours. Miles cancel, left with hours. But this now represents our time in water. So if we want the total time, you need to take the time on land plus the time in water, which we have right here. So we want to graph this and calculate the minimum y value, because that will minimize the time. So let's think about good x mins and good x maxes. Okay, so x min, how about 0? It's usually good. Remember, x is literally that value right there. Okay? What about an x max? Well, it wouldn't make sense for us to go past the shaved ice stand, which we know is an x value of 3. So x max should be 3. What about y min? How about a y min of 0? Do we get there instantaneously? No, but whatever, it'll work. What about a y max? Well, what would take the longest to get there? The longest to get there would be swimming the entire way. So that would be whatever the length of the hypotenuse is in this right triangle, where that side is 1 and this side is 3, so that would be the square root of 10 times, divided by our speed. So whatever the square root of 10 is divided by 1.5 would be a good y max. And you can totally type that into your calculator screen. You can do square root of 10 divided by 1.5, and it will then convert it to a decimal for you. So that's sweet. So let's graph this with this window and see what it looks like. Maybe gross, maybe good. Let's try it. Now, either make sure you are hitting alpha y equals to get the fraction bar if you're on a newer calculator, or if you're on an old TI-83 like I'm doing this on, make sure you put the numerator in parentheses divided by the denominator. Well, try it. See what you get. When you do that, you get a little ploopy that looks like this. So hopefully, if we were to zoom in on this on the graph, we would actually have some sort of minimum value right there. And we do, and it's hard to see, but with this window we can still calculate it. So do second calculate minimum, which is option 3. Left bound, type in x equals 0. That's going to make the left bound right there. It'll put a little caret like that on your graph. So type 0 for left bound, hit enter. Then right bound, move to where it's clearly above the minimum value. So like move your cursor over until you're on the slopey part, and maybe do it around 1.5 and you're like here, and then it'll put a little caret right there. Mine isn't actually showing that caret. It's okay. And then it says guess, and I'm lazy, and we've defined a good left and right bound. So I'm just going to hit enter, and it's going to take me to this x value, where x equals 0.258 and y equals 1.145. And now we need to interpret our answer. What does this mean? Well, x is miles and y is time, t, hours. So what this is saying is, if we hit the shore where x equals 0.258, we will minimize our time, which will be 1.145 hours. Geometry!